So now I'm going to show you how to use technology to graph some polar graphs, because polar graphs can be kind of complicated. So we're going to look at a few together. Now right here I have my beloved Desmos.com activated. The first thing I want to show you is how do you get the Desmos set up so that you can graph polar. So what I'm going to do is I'm going to go over to this wrench right here in the corner. That's the command for utilities. If I click on that, you'll notice it gives me a whole lot of options. Now I've got it in projector mode. That's going to make the lines nice and dark. And you look right here on grid. Right now it shows a grid made of squares. And what I want is a polar grid. So I'm going to click on this one right here to give me a grid made of circles and radii. So now if I click out right there, there is my grid. And we can zoom in and zoom out. If I just spin the wheel on my mouse, that'll zoom in or zoom out. And we can get quite close, or we can zoom out a bit. Let's go right about there. That should give you a pretty good view. And now let's take a look at a few graphs. Now, when you're writing a graph in polar coordinates, we don't have x and y, remember. We have r and theta. So my formulas are always going to be in terms of r and theta. So let's start with the easiest possible thing. What does a line look like? What if I just wrote r equals a number? So for instance, what if I just wrote r equals 2? Oh my goodness, look at that. I've got a circle of radius 2, which ought to make sense. R is for radius. So radius equals 2. Now, what if I had a more complicated picture? So let's try something a little bit more involved. What if I had -2 times the sine of theta? Now I can just type the word theta, and you'll notice Desmos automatically replaces it with the picture, plus 2. Well, I wonder what that would look like. Hey, look at that. And if I zoom out a little bit, we can get a better look. That's a lovely little shape. And in fact, you might want to consider remembering this shape when Valentine's Day comes around, and you can send your friends and loved ones a mathematical heart. You know, people like that. Let's try a couple more. What if I did the cosine of 3 times theta plus 2? The cosine of 3 times theta plus 2. Well, we know cosine normally goes up and down like this when we graph it. So when I graph it here, it's going to go in and out. It's going to have a bigger radius, smaller radius, bigger radius, smaller radius. And you'll notice I've multiplied by 3. Now check out what that does. Look at that. Because of the 3 right there, I have 1, 2, 3 petals on this flower. Notice the plus 2. The plus 2 gives me a radius starting of here, positive 2. But as cosine is getting bigger and smaller, I'm going in and out and in and out of that radius starting value of 2. Let's look at just a couple more. Okay, so what about tangent? What do you think tangent would look like? Well, we know normally tangent is set up in little chunks, and each chunk is kind of an S-curve. But what happens if I put it into polar coordinates? Oh, this one's just going to freak you out like you won't believe. You ready? There we go. That is tangent. And if you kind of look, you can see here's one of the S-curves. But what's happened is there's another S-curve kind of sitting on top of the first one. That's kind of the idea of what's going on there. And now one last one for you to look at. What if I did the secant of theta? Now we know secant is 1 over cosine. So this basically says 1 over cosine theta. And I could write that if I needed to. That's how I would do it on the graphing calculator. What do you suppose I'm going to see if I want 1 over cosine? Oh my goodness. That's a line. Now we know secant doesn't look like no line when we normally graph it, but oh my goodness. When I graph secant in polar, I get a line. That's pretty crazy. So that's some graphs for you to think about, and then we're going to explore a few more together in class.